It might not make that much, just depth perception probably. Maybe that's it. Maybe I just use it for depth perception. Yeah, actually, I wear trifocals, and so I wasn't able to get contacts for years. So I actually thought about getting LASIK specifically for VR. So I spent so much time in VR that when you wear glasses in VR, you can do it, but eventually everything starts getting smudged and blurry in there and things like that. So, but now the only problem I have is you stay in VR too long, your contacts start drying up.
Okay.
So you got to like pull them away a little bit and blink a bunch. So you got to take 20 seconds and go right back.
Yeah. Get back in the game.
It's like, sorry guys, I need to take a break. I can't see. All right, so let me spend about 10 minutes pulling all the stuff together we've talked about, and then let's dive into Python. Sound good? So I mentioned when I had you doing the Mendix stuff. So let's throw a little slide in here. So why Mendix? All right, so many of you didn't necessarily like the Mendix thing, right? I know some of you actually kind of seem to enjoy it, but many of you thought it was like, why am I doing this? Just a time killer, blah, blah, blah. Here's the issue with computer program, with really computer science in general. Learning to program, as I've pointed out several times, is hard. So when you first learn to program, it's a very difficult thing. And the problem related to that is that we spend so much time practicing problem solving and syntax type stuff that we never actually cover all those components that you need to put together a modern software application. So what ends up happening is you end up graduating, and maybe finally at the end after 4 years you have a reasonable competency in you could write a hello world program in a couple different languages, and you have some reasonable programming logic skills, and those kind of go across the board. You might have some people who think they're weaker than they should be, and then you have some very strong programming students. But regardless, a majority of the students that are graduating have a disproportionate strength in programming logic skills. And they don't know how to couple that with the other things that you actually need for writing modern software applications. Because you spend your first 3 programming classes basically writing just text-based software, stupid stuff, things that you don't see in real life, right? Mm-hmm. You don't go and download a piece of software or a video game and have it be a text-based game today. That was the way things were 25 years ago. So that you could make that connection, like, oh, I need a menu system, so press 1 for this, press 2 for this. That's not how it works now. You click, right? You point and click, or you whatever. And like I'm talking about VR here, you actually literally point and click. When I want to go to log into this game, I have to teleport up to the menu system. Like, okay, I want to log in with this character, then log in. You point. So what ends up happening is your last 2 years in computer science, you end up focusing on these theory classes like database and operating systems, security, things like this, artificial intelligence. But those classes are being taught from a theory perspective. So they have very little or no programming in the classes, which isn't necessarily a problem because you're learning kind of what's under the hood in those, because that's what makes you a well-rounded computer scientist, is understanding how those things are put together. But then from the perspective of going out and being productive in a job, you don't have to know how a database works in order to use a database. Just like you don't have to know how a car is put together and how carburetors work and all these things in order to drive a car. So the piece we tend to miss in computer science is that you never actually learn to drive the car. You learn how the car is built, but you don't get experience driving it. So by introducing a tool like Mendix early on, we get to see some things that then allow me to relate to it as we keep going on. So the thing we're always going to have as we go through here is we're going to have syntax. We're going to be writing Python syntax starting today and things like that. Well, Mendix largely ignores syntax. So the one piece that we're going to spend a majority of our time on, Mendix ignores. It says, look, software development is not about syntax. And that's pretty compatible with something I said the first day of class, where the programming language doesn't matter. Once you learn computer programming as a skill set, you can apply it to any language. And I run into that every 2 years. As a class, I teach every 2 years here, 2 classes, 470 and 450, systems programming and programming language theory. And then systems programming, we use C, which we've talked about. And in programming language theory, we use a language called Scheme. Now, I have quite a bit of experience in both those languages, but if you don't do anything, if you don't use something for 2 years, you're rusty, right? So when I come back to that language, it takes me like a week or two to kind of get back into the C mode. So I make stupid mistakes, things like that I don't commonly make because it's not fresh in my mind. But after a couple weeks, I'm right back up to speed with it because it's still programming. It's the same exact stuff. All right. So what Mendix does is it ignores the one piece that we spend so much time on traditionally in computer science, and we will spend so much time on it because we're preparing you for 2 different things. We're preparing you to be a computer scientist, so you should understand the theory, things like that, but we're also preparing you to get a job in the industry. All right, so think of yourself as like a NASCAR driver or something like that. I don't know a lot about racing, but I think that most of the drivers know quite a bit about how their cars work. I think that's a pretty common thing, right? Like they come off the track, we need to tweak this, that, and the next thing. They understand the technology that they're driving. But they also have that skill set in driving, a professional skill set, because they got to go out and win races. We want you to come out with that similar type of skill set. You need to be able to do, but you also need to know what's under the hood just because a computer science degree is a theory-based degree. Make sense? I think traditional computer science if we look at technology over the last 25 years, so during most of your lifetimes, hasn't technology changed drastically?
Yeah.
But education in computer science hasn't necessarily changed that drastically. We're teaching things in a very similar way to how we taught it 20 years ago. And that's a pretty common thing. Education tends to drag behind. Concordia is actually pretty good relative to a lot of schools. Being a smaller program, we really do introduce things that you don't necessarily get in a lot of schools. Other schools, your first language might still be C, which isn't it's not a very good first programming language. They introduce you to things that are even more theoretical you're going to get here. I think our program is like half applied, half theory, so that's pretty good compared to the competitors. But I'm not sure it's good enough for what we want our students to have when they come out. So what Mendix lets us do, let me kind of show these other components. Most software applications today are going to have a database. All right, so you're going to have data that gets stored up in the cloud or even on a local database somewhere. And sometimes this data is going to be persistent. Sometimes it's going to be non-persistent. So that's the difference between stuff that is stored between runs of your program versus things that are just stored between pages while you're currently using your program. This is pretty common, right? When you open up a mobile app on your phone or something like that and you log in, it's pulling in your profile information that you set up day one when you first created your account. That's like the most trivial part of any application. Does that make sense? All that stuff requires connection with a database, storing stuff somewhere. Mendix allows us to look at the applied aspect of storing things in a database. All right, you were using their data modeler, you were creating persistent data that lasted between runs of the application, things like that. Now, when you went through that, you weren't learning about normalizing a database. You weren't learning about the different kinds of databases. Who cares from a software development perspective, right? It's an important computer science theory perspective that you'll get in the, which class is it, 440 database? It's not 450. Oh, whatever it is, the database class. So in any case, being able to apply databases and seeing their use in a software application is an important thing, and we've seen that in here now. We know that if you have a program and your program needs to remember crap between runs of that program, you got to store that stuff somewhere. And the modern way of doing that is in a database, probably in a cloud somewhere. Okay? What else did we get to see? We got to see UI, US. User experience, well, it's usually UX, UI. So UX is user experience, UI is user interface. So building a graphical interface for your application. So we're used to computers where you click on an icon on your phone, or you double click on some icon on your phone on your PC, and a graphical user interface pops up that has buttons and text boxes and things like that you click on with a mouse. Those are the interfaces that we're used to using as computer users. Now, historically, when you talk about computer science development, a majority of our computer science education, a majority of the applications we write probably for the first year of programming have a dumb text-based interface. Because that's teaching you the tools to make an interface kind of muddies the water from the logic side of things. Okay? But now you've been introduced to this idea of UX, UI, and connecting that to your syntax and connecting that to your database. So we got these three pieces. I think I've mentioned this already. I've mentioned MVC in here.
Yeah, we talked about it.
Yeah.
Friday.
Yeah. So these three pieces are all glued together by something called MVC, Model View Controller. You have your interface in one place, you keep your data in another place, and you keep your logic in another place. That's how modern software development happens. All right? Mendix had you doing that, even though you didn't necessarily know that that's what you were using. You were using this MVC idea. It was shown to you in such a way that, oh, this is what's normal. I make my user interface. I make my little logic-y stuff. I create my data model stuff, and then I connect those guys up in some way. That's MVC. All right? And pretty much every software application you write today is going to have that, unless you're writing like a calculator or something like that, which, hey, is still going to have a user experience and a user interface, and is still going to have logic. You just might not store stuff in a database. Although my very first application I wrote for iPhone when it first came out, which made way more money than it should have. And I was here at Concordia. This is, I guess, a decade ago or so. We were getting ready to play Dungeons and Dragons, the tabletop role-playing game, and I just moved here. So my dice and stuff weren't unpacked. They're still in boxes somewhere. So being a good computer scientist, I decided, I'll just write a dice roller. And iPhone just announced their app store. It wasn't live yet, so let's write a dice roller for iPhone. You can still find it out there, D20 gaming dice. Here, let's just do a quick search. Oh, by the way, a week from today, the GRACE meeting, Women in Computer Science group that we have here on campus, as part of the computer science department. I'm teaching a cryptocurrency demystified thing in the, where is this thing? Terrace room, 7 o'clock a week from today, 7 p.m. Everybody's invited to come. So I actually encourage all of you to take part in our GRACE group. It's not just for women. It just happens to be an ACM chapter that is women in computer science. There's plenty of male members and things like that, but that connects you to some of the things that we're doing in technology, and also helps the department by having enough people at the meetings and that kind of stuff. And you get some free food sometimes. But I encourage you to attend this event if you're just interested in what this cryptocurrency, Bitcoin-y stuff is all about. We'll probably have another one relatively soon dealing with virtual reality and things like that I suspect I'll also probably teach. But strongly encourage you to join the GRACE group, which is through this department. If you're interested in information about that, you can contact So Alexis is the president of our chapter. She's, I think she's officially listed as a senior in computer science, but she's, I don't think she finishes this year. I think she finishes next year. She's a double major, I think. So anyway, she's the president of the chapter. If you want to know when meetings are, or find out more about it, or things like that, strongly, strongly, strongly encourage you to get involved, especially the women in the department. But like I said, we don't have a generalistic ACM chapter, which is typically for everyone. So our first chapter was created by a whole bunch of women in computer science. Well, it's still an ACM chapter, Application for Computing Machinery. So, it's still official. It's still, it's not just for women. It's the punchline. Okay, so I strongly encourage you to get involved in that at some level. All right, so I was talking about D20 gaming dice. So let's look at my beautiful first interface. Historically, it has shown up in this search. Here we go. Look at that. Okay, now this was the normal version. There was also a pro version of gaming dice. So this is one I first put together, but the pro version used a database. It also allowed you to create formulas. So like if you might do 2d6 plus 8 or something like that, if you're, that might be your fireball attack or something. So then you could store those things so that when you next time you played, there was another tab on here. You'd click it, and you had all your rolls for your character that you can just click on it and would do that roll. So an app like this one here didn't use a database, but we have a obviously beautiful user interface. Okay, this was way ahead of its time. And this user interface had behind it some programming logic. Okay, and we used MVC to glue those two together. In the pro version, I had my interface. It looked just as awesome. It still had business logic behind it, but it also had a remote database. We used a tool called Parse, which was a database in the cloud for storing the information related to this so that the next time you opened up your app, it would bring in the roles that you had previously stored so that the next time you need to cast a fireball, you just click on fireball attack and it rolled the dice and you're like, that's what I rolled, instead of throwing a whole bunch of dice, because that's what geeks do. That make sense?
Are you really going to change anything?
That changed my wallet quite a bit. I'll tell you what, when the Apple App Store went live, everybody and their brother just downloaded every single app. There were probably grandmas that had my app on their phone. They didn't know what it did, but they downloaded it. This one was 99 cents. The other one was $1.99 for the pro version. Huh?
Stepping up the price there.
Yep. That was before the race to the bottom. I didn't care what they used it for. All right. Related interesting story. I also had the first, like the stock quote stuff. I had the first two real-time stock quote applications on the App Store. One was called Portfolio RC. The other one was called, or Portfolio RT. The other one was called Quotes RT. I actually got sued by the NASDAQ and the Dow Jones once they decided that, I didn't quite get sued. I got threatened to be sued. It was cease and desist. Once they decided, people are using our data inside of apps, we should charge them for that. Well, I wrote it way before they had that. Well, then all of a sudden they said, well, you're pulling our data for free. You can't do that. But by that time, all the big banks, E-Trade and Ameritrade and stuff, were already on there. So I just sold my technology to E-Trade and I moved on with life.
How much?
A lot. A lot. Could buy a lot of pizzas. A lot of pizzas. Buy a lot of cars. Yeah. Actually, the Dice Roller app was the one that made ridiculous money. The quote one was made. That one was more money per app. It was like $12.99 for Portfolio RT, but there was a smaller group of people because that came out probably 6 months after the App Store went live, but it still did all right. So in any case, even that simple little app that I just showed you requires some business logic, requires data stored somewhere, requires a user interface. Okay? And those are pieces, these two pieces here are often not even introduced in computer science education until you're a second semester sophomore or a junior, or even later. In fact, when you get into the database class, typically this is being shown from a theory perspective, not applied perspective. So you might not write any application that actually plugs into a database. Instead, you're just working with databases. And then all of a sudden you have this disconnect. Like, okay, well, I know how to program and I know how to database. Okay, well, how do I connect these guys together and make them do something? Well, now you've already seen that with Mendix. Now, you might not want to use Mendix as your go-to tool for doing this, but you've at least been introduced to the idea that I have a program that connects to a database, that connects to a user interface, and connects to some programming logic. Right? Now, we add some stuff to this. We also have collaboration tools. So something that we start using in the second half of 250 probably when we start doing Android development. So I try to start throwing some of that user interface stuff in when we do Android development because you're kind of forced to create another user interface. But we start using a collaboration tool in there called GitHub. Now, some of you maybe are familiar with GitHub. You probably haven't used GitHub for what it's meant to be used for. You use GitHub to download some piece of software that is available out there that's open source. So they give you a GitHub link and you download it and you run it from there. That's just the way that they distributed the software, and that's what I use it for in my classes. So I teach you. I usually give you a starting point for your Android app. I push it to GitHub, then you guys clone it. What you do is you fork it to your account in GitHub, then you download it from your account. Do your homework and push those changes and provide me the link. So I can grade your homework and see all your source code files in an easy way instead of you submitting a zip file or something like that with 20 source code files. Right? So you're using that tool not for collaboration with other developers, but for me to collaborate with you by providing you a starting point, and then for you to, I guess, collaborate with me by sending me your solution. So you're getting that information, but you're not actually using that tool for what it was meant to be used for. And that's having 5 or 6 or 7 developers all working on the same project, all checking out stuff, making changes in different parts of that application, pushing those changes, and having this tool up there, merging them together or keeping track of what's changed, what hasn't changed, who changed what. Okay, so that's kind of like the team server on Mendix. It allows multiple people to collaborate. All right, so that's something else that you wouldn't have been introduced to until later on, and you would have only been introduced to it at a very small level. Now, having said that, this is kind of difficult to even introduce at the college level for a couple of reasons. You're going to do some collaboration in the software engineering class when you are currently in 300. Is that right? Yeah, I think that's when you'll take the 370 is the software engineering class. Actually, you might take it when you're in 250 next semester. Well, wherever it is. So you do some group work in there, but as you know from other classes you've had in school, group work with students tends to not go that well. You usually have 1 or 2 people that does all the work, right? Where if you're out in industry and you have 4 people on a project and they're all being paid a salary and 2 people aren't living up to their end of the bargain, then people are going to get fired and lose their money, right? So people take it a little bit more seriously. Well, as students, I remember when I was in school, it didn't even matter what the intentions were of the other people in the group. If I was the best programmer in the group, well, I'm not going to let anybody else program. I want an A. Okay, this idiot over here could just watch. Okay, you watch, you don't touch anything. Yeah. Well, that's not, you're not actually learning anything with that, right? So you get those scenarios as well. So it's not always about slackers in the group. It might also be people in the group that don't want to deal with the C students' average work. It can go all sorts of ways. But the punchline here is that group work at the college level doesn't work as well as we would hope. Okay, where in industry, it's a requirement. Okay, but the idea is you're getting paid for it, so you're heavily motivated to be good or to, kind of have your specialty or something like that. So again, this is a tool that really isn't typically introduced. And then another piece is third-party APIs. And to be honest, it's not uncommon for you to get your entire 4-year degree in computer science and maybe never communicate with a third-party API. So third-party APIs, that's how you bring in external data sources into your application. For example, you go in, how many of you are football fans in here? Or basketball fans, some sports fans? You probably have an app on your phone that allows you to kind of pick your favorite teams and see sports scores associated with those teams. All right? Whether it's an NBA app or an NFL app, or if you're involved in fantasy football, that kind of stuff. You have these apps for that kind of stuff where you care about the current score. Well, even if you just have a widget on a web page that's showing the current score of the Packers game or something like that, and that thing's constantly updated, that score is relative to something that's happening in Green Bay or wherever they're playing, right? So somebody is grabbing that score, storing it up in the cloud, and you have hundreds of applications around the world that are hitting that data source, that API, and saying, I want to know what the current score is. Give it to me. Downloading it, bringing it into their app, and updating their user interface with that information. Okay, so we're connecting into other people's data. This is our data. This is the stuff that we're storing between runs of the application. Well, here's other people's data. When I wrote that real-time stock quote application, I was connecting into the API associated. Well, they didn't have APIs then. Now we constantly pull APIs. Pretty common that you have a mobile app that lets you make a payment through PayPal or that kind of stuff, right? So all these major companies have programming interfaces, application programming interfaces, an API, also abstract programming interface. They kind of get used interchangeably. But it's a set of tools that allow you to ask for some of the services that those third-party places provide. Well, so the Dow Jones and the NASDAQ, the stock market exchanges, they didn't have APIs in the early days of the App Store. So what I took advantage of is I took advantage of Yahoo Finance and Google Finance. I loaded their web pages, screen scraped the data. So I took the HTML that was behind the scenes, read it in as a string, parsed out the pieces of information. Here's the stock ticker, here's the current price, here's how much it went up. So I let my program do all of that. So I had to write the business logic to piece out the mess of text and just get the data points out of it and then show it on my screen. So I basically used a very inconvenient API that they didn't know they were providing. But the point is that most applications that we have today rely on this third-party API idea. A lot of the data you're showing isn't your data. Make sense? Okay, so this is another piece. Now, I actually did the thing you went through in Mendix. I don't think that one had you touch third-party APIs, did it? Where they had you connect up to what's called a JSON. They described the JSON data. I don't think it did, but Mendix does support it. So Mendix allows you to say, okay, I want to have a data table, and I want this table to be hooked up to this third-party API, and then you tell that table what that data looks like. The data comes in this format called JSON that just is a bunch of name value pairs. It's going to look like our dictionaries. It's going to kind of be like structs that we talked about in here. Just a text-based representation of a struct that says, team name, opponent name, current current score or something like that. If we're looking at NFL scores or that kind of thing. Okay. So connecting in with third-party APIs is another piece that's pretty common in modern software applications, and we don't see it. as a computer science student. Maybe you are thrown to the wolves as a senior when you're doing your senior seminar project, where you have all these kind of soft skills coming into your senior project, but you haven't actually put those things together. So then we just throw you into the Shark Tank and say, go, here's this project that's going to take you 300 hours of work to do. And you're going to be taking these skills that you have in these different things, and you've never actually connected those things together, but now you're forced to connect them together, and you don't even know where to start. That make sense? So using a tool like Mendix early on and then referring back to that through your first several classes allows us to kind of see the role of these pieces in the software development lifecycle, while we're focusing on this syntax thing, which is going to take us some time to get through, because that's going to be difficult for us. We're all used to dragging and dropping things, where the real difficult thing with the Mendix stuff was when maybe the video didn't quite match up to what you were seeing on your screen, right? You're like, look, I am clicking there. This is where that's supposed to be. But that was a move that you're all used to using, right? You're used to watching videos. You're used to clicking on stuff. So just when the two didn't line up, you had a normal human frustration. But it's not dissimilar to if you were watching some how-to video making lasagna and they used the wrong, I mean, they told you needed this much onion, but they used a different amount of onion and you got confused or something like that. All right, maybe your grade didn't depend on it, but you know, punchline is that we're going to spend the next while writing command line looking stuff, these ugly programs that are going to feel boring, but they're also going to be way more difficult for you to write than when you were working with Mendix. Because now you're thrown into the deep end, but at least now you have a context of why this is important. So in Mendix, this syntax stuff was represented by microflows. Microflows. Oh. So Mendix advertises itself as a low-code rapid application development tool. So you use microflows, drag and droppy type stuff, rather than writing syntax. Okay? So they've replaced this piece that we're going to spend so much time on with this, which still wasn't the easiest thing in the world, but the application they had you do with the microflow stuff was very much just asking some simple questions. Okay, we go back to this idea of how do humans solve problems. We use our memory, we ask questions, and we have repetition, right? So memory here was storing stuff in either persistent or non-persistent ways. So with our data models, throwing it in the database between runs, blah, blah, blah. Okay, that's our memory. Asking questions we did through the microflows with conditionals. If this is true, do this stuff, otherwise do this stuff. And we did some of that stuff with the microflows. And then the repetition stuff is when you click the button and several things happened all at once, and that was also represented in the microflow stuff. Okay? So we now have this context for these pieces that are not going to be introduced to you until later on. So now I can introduce them through some of our assignments. Once we have a fighting chance with the syntax, once we feel like, okay, we're okay at Python, or we're okay at, the easiest way to start incorporating these things is going to be when we get into Android about halfway through next semester. But at that point in time, you kind of realize that, it would be nice to have data available to us between runs of this application. So now we maybe integrate a database into our Android application. And that's something that we typically would not do, but now that you have a context for it, what's the purpose of that thing, we can now do it. And it doesn't necessarily matter if you understand how that whole interface is working, right? We don't have to talk about how it's bolted under the hood. We just have to say, here's the 4 steps for connecting your Android project to this database. Do these 4 things, and now the 2 are talking. That make sense? And then all of a sudden, you can now put that into an app. The idea being that at the end of, by the end of 250, by the end of the next class, you could be writing mobile apps that look even better than my beautiful dice roller. Okay?
That's going to be a challenge.
It would be a challenge. In my defense, the interface building tools were not as good then as they are today, but they were good enough to do something better than that. But that's not my repertoire. Dr. Wall teaches animation and design and that kind of stuff classes. So you can go talk to them about making stuff look good. Okay. I'm pretty good at making them work. Yeah, so I spend a lot of time here and working, connecting to this and connecting with this, and basically pretend this doesn't exist. But I'm pretty good in those other areas. I have some disproportionate strengths there, and basically non-functioning autism over here. I actually do have autism, so I have a form of autism called Asperger's syndrome. If you've heard of it before, have you seen Big Bang Theory? Yeah, I got the same thing Sheldon has. It's pretty funny. When I'm at home, my wife, you get the filtered version of me here. I'm very strange at home. I'm saying I'm very strange at home. I'm like, well, he's pretty strange in the classroom too. But, yeah, so this is all part of that. I don't pay attention to user interface. All right, so in any case, do we kind of see the rationale for Mendix, why that kind of idea is there? All right, so let's go ahead, and I'm going to bring up, do I have a Python interpreter up here somewhere? Okay. You can find lots of these out there. I'm actually going to write some of the Python probably from the command line on my machine. If you read chapter 1, I think I ask you to read through and get some interface set up? Yeah. Okay. So you could do something like this if you prefer. Early on, a web-based Python interpreter will be fine. You're not going to be creating these gigantic applications. But before long, you're going to be wanting to probably have a text editor, something for writing your code. I tend to use a tool called Atom, but you can use Notepad. You'll get tired of Notepad pretty quick. And then I like to run an interpreter from the command line. All right. But early on, I'll probably use something like this just because it's quick and dirty. It will allow me to show you some stuff. So in any case, if we jump back here, and just as a quick crash course, and this is something you can do for any programming language. Okay, so this is learn any language. We remember that humans solve problems with memory, asking questions, repetition. All right, those three things, every single programming language will have facilities for. So what you need to do is when you're introduced to a new language you haven't worked with before, you just have to ask, how does that language provide memory? How does it implement variables? Okay? Now, if we just quickly think about Python, we want to kind of decide, where does Python live? Which lens are we looking through with Python in terms of all the different kinds of languages? There's 2 kinds of languages, there's 3 kinds of languages, all that stuff. So Python is a general purpose, object-oriented, interpreted, high-level, loosely typed programming language. It just so happens to be fairly popular in web, but it's also fairly popular in machine learning type stuff. So Python is one of these languages. It's one of the reasons we pick it as our first language. Is it's a little bit friendlier initially than like a C or a C++ or a Java. But on top of that, it's a language that's heavily used in industry. Okay, so very likely when you get out of school, you will use Python at some point.
So what about Java?
You'll use Java too. You're going to learn Java next semester. But the point is that it doesn't matter what language you're using. To learn any language, you're going to say, how does it accomplish these 3 things? And now all of a sudden, you're solving a large classification of problems in that language. And then from there, it's just a matter of learning the little idiosyncrasies of a language, learning kind of its strengths and its weaknesses. We talked about PHP, for example. PHP is a general purpose language, but it has some stuff built into it that makes web-based things easier. So you would still say, how do I do memory? How do I do variables in PHP? How do I ask questions? How do I do conditionals in PHP? How do I write loops? How do I write functions in PHP? Once you have those things under your belt, you can now solve a lot of problems in PHP. Then you'll start stumbling into PHP's strengths and weaknesses. What things is that particular language good at? What things is that particular language not so good at? All right, then you can decide, is this the right tool for the job? Right? If you only know one programming language, then you tend to make that the right tool for every job. Right? Otherwise, if you're not scared of other languages because you've acquired computer programming as a skill set, now you can look at a job and say, okay, this is what I'm being asked to do. Let's do a survey of programming languages. Spend a half hour thinking about, here's the types of things I need to do for this problem. Are there any languages out there that lend themselves to those kinds of problems? So maybe you look at a couple of languages that are options and you decide, okay, given my time constraints here, are the languages that I'm already familiar with, can they be applied to this problem? Or am I really trying to, stick a square peg into a round hole? Okay. Versus these other languages, which I'm telling you is once you've learned computer programming as a skill set, you can pick up these other languages quickly. Are some of these languages kind of custom built for solving this exact problem? If they are, I would probably benefit myself by spending a little time getting up to speed on one of these other technologies and then applying it to the problem they were basically built to solve. That make sense? Always use the right tool for the job, but that, we don't always apply that in real life, do we? If you're solving some problem around the house, the right tool for the job might cost a lot of money and be a 20-minute drive to Home Depot, okay? Where you have a hammer and a foot. and you break the wood in half. Right? It's like, that's a clean enough cut. Now it fits in the spot it needs to fit. Just kind of bang it on the ground a little bit, get the sharp edge off, and now it's not the best solution, but it's a solution, right? It goes back to the whole thing that we can use duct tape to fix anything, right? Might not be the right tool for the job, but if you watch Mythbusters, duct tape was able to do it. Didn't they lift a car with duct tape?
Yeah, that was like made a boat.
Yeah, all sorts of stuff. All right, so learning any programming language, we're going to say, how do you do memory? How do you ask questions? So how do you represent conditionals? And repetition, how do you do loops and functions? Once you have those three things down, you've unlocked that language. Now it's just a matter of applying your problem-solving skills, which that's your weakness right now. We're going back to week 1 of this class when I said the difficult thing with learning programming is that human beings are so good at solving problems that we have trouble articulating how we solve them, right? Python is not going to be our challenge here. Many of you are going to feel it's the challenge, but that's not the challenge. The challenge is going to be coming up with the solution to the problem from a step-by-step approach, from a recipe approach for solving a problem. And then once you have that, converting it into equivalent Python is going to be fairly easy. Early on, you'll make little typos and that kind of stuff, but that's not the trouble. But you're going to trick yourself into thinking that's the hard part. Okay? So doing these three things in Python. Let's look at variables quickly. We already have a couple of them available to us. Okay, so I can say my name is Mike. Okay, my age, I just turned 21. Got my free margarita over at Highland House. Who actually thinks I'm really 21? A couple weeks ago, I turned 21. This is early. I started losing my hair very early. The grayness. Actually, right now, I think my beard is short. I don't have too much gray in it right now, but yeah, I'm a little bit older than 21. I've almost been teaching 21 years. I actually just turned 40. Yeah, I started teaching when I was 21. All right, so name, age, something like that. So now we have a couple of variables. I'm remembering my name. I'm associating a variable name with a value. I'm associating a variable name with a value. That's variables in Python. Okay? Next, conditionals in Python. We accomplish conditionals. We ask questions using something called an if statement. So we say if. Maybe we say something like age less than 21. And you put a little colon there. Press enter. Now, tools like this will automatically indent for you. One thing we want to remember about Python, I'm going to go ahead and put it on a slide real quick, and I know we're out of time. But this is an incredibly important slide. Indentation is extremely important. Other languages, in the way they're structured, indicate that it's a good idea to indent. Another reason why Python's a good first language is you are absolutely required to indent stuff under your code. This indentation thing here, print no beer for you. Okay, that guy right there, that only works correctly if it's indented under that if statement. What is it? This bud is for you. All right, so I'll go ahead and execute this. The age is 21. Oh, sorry. Small little syntax error. Here's the this bud is for you. Now I'm going to change the age to 11. We'll execute this again. No beer for you. All right. So let's pause it right there. No homework for Wednesday. I will put up the Bible homework today, so maybe try to knock that out for Wednesday because I will be giving you a programming assignment on Wednesday, and that's going to be a little time consuming. Okay. Prepare your timing for your first several programming assignments. They're going to be harder than you think they should be. All right?